Lesson 6.3, Data Sets and Outliers. Okay, the mean and the median of a data set, those are measures of the center because they indicate the middle values of a data set. Again, the mean is the best center if we have symmetrical data set, and the median is the best center if we have an asymmetrical data set. And these help compare data in relation to the center. The range, the interquartile range, and the standard deviation are all measures of spread, or how far ranging the numbers in a data set spread out. They help identify the shape of the data, how far the data reaches, and how far from the center a particular data point lies. They can also help to identify potential data outliers. So let's look at how to analyze a set of data from a dot plot. The following dot plot indicates the height of players on a basketball and on a soccer ball team. So we have the soccer players and we have the basketball players. And just looking at this, you might think, okay, on average, the basketball players are taller than the soccer players. There's an asymmetricalness to basketball player height. Soccer players are more symmetrically height ranged. You can just gather some ideas about the data from looking at the picture. But we want to actually analyze the data. So the first thing we want to do is we want to make a list of the data points for each team. I should say team. In numerical order. And so I've already done that on the soccer team. So I started with the soccer team. We had one 65-inch player, two 67-inch players, three 69-inch players, three 70-inch, three 71, four 72s, six players that are 73 inches tall, four 74s, three 76s, 180, and 185. Forgot that one was added on there. And then for the basketball team, we have a 66, two 73s, a 75, two 78s, four 79s, two 80s, two 81s, two 82s, and three 84s. Okay, gotta keep adding that 85. All right, so we want to find the mean height of the players on each team and compare them. So you remember, to find the mean, this is the average. Okay, so we're going to add soccer players. And then we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, because that's how many we've added together. So the sum of all the soccer player is 1927. And I want to divide that by 31. And that's going to give me the average height. No, that's wrong. Okay, hold on. I need to redo that. I must have made a mistake somewhere. And this is actually good because when I divided by 31, I got 62. 62 is lower than my lowest number. So the average cannot be lower than my lowest number. So that's how I knew I made a mistake. So I'm going to recalculate. Okay, when I recalculated it, I got 2244. And I think what happened is I tried to put this entire string of addition into my calculator all at once, and I ran out of digits, and so it stopped adding even though I was still pushing buttons. So I'm going to take 2244 and I'm going to divide it by 31, and this makes more sense. The average height of the players on the soccer team are 72.39 inches. Now to find the basketball team average height, I'm going to take all of the heights of the basketball players and I'm going to divide it by 19. Okay. When I add the basketball players' heights together, I get 1497, and I divide that by 19, which gives me an average height of 78.79 inches. Now, based off of our average height, I can say that yes, my initial assumption that the average basketball player is taller than the average soccer player is true. Okay, now we found the mean, which was the average. Let's find the median, which is the middle. Now I had 31 soccer players. 31 divided by 2 is 15.5. So if I take 15 in from this side, and I come 15 in from this side, that's not right. I did something wrong. 1, 2, oh, I forgot the 85. That's what I did wrong. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This will be our median, 72. So our middle height is 72 inches, which is actually very close to what our average height was. Now on the basketball team, we had 19 players. We divide that by 2, and we get 9.5. So I come in 9 from this side. Nine from that side, and I get a middle height of 79 inches. Now we want to find the range, the IQR, which is the interquartile range, and the standard deviation for each set of data. Okay, so we needed to come in, first we need to add our first we need to add our 85. We need to come in 15 from each side. Here's our median at 72. So that's our second quartile. Now I have 15 numbers, so if I take 15 and I divide that by 2, I get 7.5. So if I come in from 7, I find my first quartile and my second quartile, or my third quartile. Okay. The range is my largest height minus my smallest height. So my range is 20 inches. My interquartile range is quartile 3 minus quartile 1. So my interquartile range is 3 inches. This tells me that 50% of the basketball players are within, or sorry, the soccer players are within 3 inches of each other. Because between Q1 and Q3 are 50% of my data points. And then to find the standard deviation, I need to go back and look at my mean. And my mean was 72.39. Now remember, to calculate the standard deviation, I take the sum of all of my x's minus my x bar squared divided by the number, and I take the square root of that. When I calculate this, and again, if you need to review this, if you go back to video 6.02, I show you how to go ahead and calculate out the standard deviation. When I calculate the standard deviation, I'm going to get 3.76. And that tells me that the majority of the heights are within 3.76 inches of the mean. Okay, if I use the basketball team figures, okay, here is my median, which is quartile 2. Here was quartile 1. And here's quartile 3. My range is 84 minus 66, which is 8. No, is it 18? Yeah, 18. My interquartile range is 82 minus 78, which is 4. That's inches. My standard deviation, again using the same formula, my standard deviation is 4.36. So that means that 50, or most of my heights are within 4.36 inches of the mean. So what does this information tell us? Okay, first of all, our median and our mean told us that on average, basketball players are taller than soccer players. Okay. Our range information tells us that soccer players have a wider range of heights. However, most are closer to the average height because their standard deviation was only 3 point something, whereas the basketball players had a standard deviation of 4 point something. So basketball players have a smaller range, but the average player height has a wider range. Okay, so outliers are data points that are significantly higher or lower than the rest of the data. So box plots can be useful for identifying outliers, but they're not necessarily necessary for identification. So we had the basketball team, and we want to see if there are any outliers. So I'm going to make a box plot without making a box plot. I've got my numbers in order, so here's my median. Here's Q1. Here's Q1, Q2, Q3. Okay. Now, if you recall, in order to find an outlier, we talked about this. See how I'm kind of making a box plot? We talked about this in lesson 6.2. What we do is we take our IQR and we multiply it by 1.5. So in this case, my IQR is 82 minus 78 times 1.5. 82 minus 78 is 4 times 1.5, which gives me 6.5 inches. Okay, so anything that is more than 6.5 inches from the median is an outlier. So we take our median. So I have 79, and I take 79 and I add 6.5 inches, and I take 79 and I subtract 6.5 inches. So 79 plus 6.5 gives me 85.5. 79 minus 6.5 gives me 72.5. Anything higher than this or lower than this is an outlier. But we don't have anyone taller than 85.5 inches. However, we do have someone lower than 72.5 inches. Our 66-inch basketball player here is an outlier. So let's look at our soccer team. Here's our median. Don't forget that 85 goes on the end. So I go 1, 2, 4, 5, 6, 7. There's Q1. Here's Q3. Sorry. Here's Q3. Not this one. This one. Okay, so our interquartile range, which is Q3 minus Q1, is 74 minus 70, which was 4 inches. So I'm going to take that 4 times 1.5, and that gives me 6. So I'll take 72 plus 6 and 72 minus 6. 72 plus 6 is 78. 72 minus 6 is 66. So anyone taller than this or shorter than this is an outlier. 65 is an outlier. And then 80 and 85 are both outliers. So in this team, we have 3 outliers. So if we remove any outliers from the data set and recalculate the mean, median, range, and standard deviations, how would this change the results? Okay, so we have our soccer team. Don't forget there was an 85 on there. And we had these outliers, so we're taking those out. And on our basketball team, we had 1 outlier, so we take him out. If I calculate the mean, median, and range for each of these now, so we have the soccer team, and we have the basketball team. We're going to have our original data and our new data. For our basketball team, originally we had an average of 78.79. We had a median of 79. We had a range of 84 minus 66, so our range was 18. And we had a standard deviation of 4.36. Recalculating with our new data, we get an average height of 79.5. We get a median of 79.5. Our range becomes 11, and our standard deviation is now 3.24. On our soccer team, originally we had an average of 72.39 inches with a median of 72 inches. We had a range of 20 inches, and we had a standard deviation of 3.76 inches. If we take the outliers out, our new average height is 71.9 inches. Our new median is still 72 inches. Our range is now 9 inches, and our standard deviation is now 2.4 inches. So what does this do? How does this change the results? Well, on the basketball team, the average height increased because we took away the shortest player. On the soccer team, the average height decreased because we took away 2 of the tallest players and only 1 of the shorter players. Our median stayed the same on the soccer team, but in the basketball team, what we got was a median equivalent to the mean, which means we got a more symmetrical range of data. Both cases, our range was lowered because we took the outliers out, so our data sets are closer together. And in both cases, our standard deviation reduced, which means that most of the players are closer to average height now than they were before. And that's what happens with outliers. That's how outliers can change the data. And for data analysis, because the outliers can change the data so much, in order to get more accurate to the average, we remove the outliers and calculate the data without them.